Good morning, all. Myself, Aman, a student from Vellore Institute of Technology. Now, I am going to teach you about the equipments which are used in the food industry. Introduction to food processing equipment categories. Uh, the modern food industry operates on a massive scale, and its success hinges on the ability to produce consistent, safe, and high quality products efficiently. The equipment detailed in this document is more than just a collection of machines. It represents an integrated system designed to control every variable in the production process, from raw material intake to final packaging. Each step is managed by specialized technology. The production workflow is logically divided into four foundational stages, each with a distinct purpose. The first one is preparation, and the next one comes processing, preservation, and packaging. In preparation, which includes modifying raw ingredients into a usable form. In processing, actively cooking and transforming these ingredients. Preservation, ensuring the product remains stable and safe for consumption over time. In packaging, protecting the final product and preparing it for distribution and sale. Preparation and handling equipment, the foundation of quality. This initial stage is critical because the quality of the final product is determined by the quality of its initial preparation. In preparation and handling equipment, it consists of industrial mixtures, planetary mixtures, spiral mixtures, etc. This comes under the type of mixtures, and also it consists of cutting and grinding systems. In industrial mixture, the goal of mixing is to achieve a homogeneous blend of ingredients, which is essential for consistent flavor, texture, and performance in later stages. Planetary mixture is a type of industrial mixture, and these are named for the motion of the mixing agitator, which spins on its own axis while also orbiting the bowl. This ensures the entire batch is thoroughly blended without leaving unmixed pockets at the edges, making them highly versatile. Spiral mixers is another type of industrial mixture. These are specialized for dough. Unlike other mixture, the ball rotates while a spiral-shaped hook remains stationary. This method is much gentler, developing the gluten structure in bread dough without overworking or overheating it, which is crucial for a quality fine loaf. Next comes ribbon blenders. These are ideal for dry powders or solids. They use a horizontal ribbon shaped agitator to gently tumble and mix ingredients, ensuring an even distribution without breaking down the particles. The next preparation and handling equipments are cutting and grinding systems. The primary purpose here is size reduction and texture modification. It includes bowl choppers. This equipment uses a series of curved knives rotating at high speed in a large bowl. This action is so fast and intense that it can create an emulsion, finely dispersing fat and water to create the tightly bound texture found in products like bologna or hot dogs. Meat grinders and vegetable dicers are another type of cutting and grinding systems. By reducing the size of ingredients, these machines increase the surface area, which allows for faster, more even cooking and absorption of seasonings. The variety of plate sizes allows for precise control over the final texture of the product. Processing and cooking equipment. This is where the chemical and physical transformation of food occurs, primarily through the application of heat. In cooking equipments, it consists of industrial ovens, commercial fryers, and steam kettles. In industrial ovens, there are mainly three types of ovens. One is convection ovens, the other one is deck oven, and the next one is combi ovens. Convection ovens. By using fans to circulate hot air, these ovens eliminate hot spots and transfer heat more efficiently than conventional ovens. This results in faster cooking times and exceptionally even browning and baking. Deck ovens. These ovens use conduction, direct heat transfer from the hot stone or deck to cook the product. This creates the characteristic crisp, browned crust desired for artisanal breads and pizzas. Combi ovens. These are the most versatile, combining steam and convection heat. The steam injection keeps proteins like chicken or roast moist, while the dry convection heat provides the necessary browning and crisping. Next comes under this cooking equipment is commercial fryers. Commercial fryers is mainly of two types. One is continuous fryers. These are designed for mass production. A conveyor belt moves food items through a long vat of hot oil at a controlled speed, ensuring every single item is fried for the exact same amount of time, guaranteeing uniformity. The other one is pressure fryers. By cooking in a sealed, pressurized environment, the boiling point of the water inside the food is raised. This allows the food to cook at a lower temperature and much faster, trapping steam and moisture inside for a juicier final product. The other one is steam kettles. The jacket is a hollow space surrounding the kettle where steam is circulated. This provides a gentle, uniform, and indirect heat source that prevents scorching, which is critical when working with sensitive ingredients like sugar in confectionery or dairy in sauces. The other one which comes are refrigeration and cold storage systems, which are mainly used to extend the shelf life. After processing, the food must be prevented from spoilage caused by microbial growth and chemical changes. For that, we'll use blast freezers, walk-in coolers, and controlled atmospheric storage. Blast freezers. In blast freezers, the key to quality preservation is minimizing cell damage. Slow freezing allows large, sharp ice crystals to form, which puncture cell walls. When the food thaws, moisture leaks out, resulting in a mushy texture. Blast freezers freeze food so rapidly that only very small ice crystals can form, leaving the cellular structure intact and preserving the original structure and nutritional value of the food upon thawing. Walk-in coolers. These maintain a temperature range of 0 to 4 degrees Celsius. The specific range is just above freezing but cold enough to drastically slow the growth of most spoilage bacteria and pathogens, thereby extending the shelf life of fresh products. Controlled atmospheric storage. This technology effectively puts produce to sleep by reducing oxygen and carefully managing carbon dioxide and humidity. The natural respiration and ripening process of fruits and vegetables are slow to occur. This allows produce like apples to be stored for months while retaining their freshness and crispness. Packaging machineries. The final protective layer. Packaging serves multiple roles. It protects the product from physical damage and contamination, provides a controlled environment to extend shelf life, and communicates essential information to the consumer. In packaging, automated filling systems, heat sealing machines, and label application systems are the main equipments or machineries. Precision is paramount for both regulatory compliance, net weight requirements, and cost control. These systems use volumetric or weight based methods to ensure every package contains the correct amount of product. Heat sealing machines. Creating an airtight hermetic seal is one of the most critical steps in preservation. The seal prevents oxygen and microorganisms from entering the package, protecting against spoilage and maintaining freshness. Label application systems. Beyond branding, labels are crucial for traceability. High speed systems apply labels containing barcodes, lot numbers, and date codes, allowing a product to be tracked throughout the supply chain. This is vital in the event of a product recall. The next one which comes is quality control, sanitization, and compliance, which are the non negotiables. These systems are the backbone of food safety, designed to prevent, detect, and eliminate potential hazards. Inspection instruments, metal detectors, and X ray systems. These act as critical control points to detect physical contaminants. Metal detectors are effective against metals that might break off from machinery. X ray systems are more advanced, capable of detecting denser, non metallic contaminants like glass, bone, or stone, and can also perform quality checks like verifying fill levels or spotting missing components. Cleaning and sanitization equipments, CIP systems or clean in place systems. This is a cornerstone of modern sanitization. Manually cleaning complex pipework and tanks is difficult and prone to human error. CIP systems automate this process with a validated sequence of rinses and chemical washes, ensuring a consistent and verifiable level of cleanliness every time, which is essential for preventing cross contamination and removing allergens. UV sanitization units. Ultraviolet light is a chemical free method of sanitization. It works by damaging the DNA of microorganisms like bacteria and viruses, rendering them unable to reproduce. It is used to disinfect surfaces, air, and water streams. High pressure washes, powerful cleaning equipments removing stubborn residues and contaminants from surfaces and equipment. Variable pressure settings accommodate different cleaning requirements safely. Safety standards and regulatory compliances. In these safety standards, food equipment must meet stringent safety and hygiene standards to protect consumers and ensure regulatory compliances. Here comes HACCP, FDA regulations, and ISO certifications. In HACCP, this is the Hazard Analysis and Critical Control Point. This is a proactive science based system for managing food safety. Instead of just testing the final product, HACCP identifies potential hazards at every step of the process and implements controls to prevent them from occurring. FDA regulations and ISO certifications. These are comprehensive standards that govern everything from the materials used in equipment construction to ensure they are non toxic and non absorbent, to the sanitary design of the machinery to ensure it can be easily and effectively cleaned. The future trends in this equipment industries are future the digital transformation of food processing. The industry is evolving with the integration of automation and smart technology to enhance efficiency, safety, and data driven decision making. Robotic automation. AI powered robots are increasingly used for highly repetitive tasks. This includes pick and place operations on packaging lines, butchering, and sorting. The benefits include increased speed, unparalleled consistency, and a reduction in both labor costs and human error. IoT integration. IoT is the Internet of Things. By embedding smart sensors in equipment, facilities can monitor operations in real time. A sensor on a motor can track its temperature and vibration, predicting a failure before it happens, which is known as predictive maintenance. Other sensors can monitor temperature, pressure, and flow rates, providing a wealth of data that can be analyzed to optimize processes, reduce waste, and improve efficiency. In conclusion, as demonstrated, the equipment used in the food industry forms a sophisticated interconnected system. It combines principles of mechanical engineering, thermodynamics, and food science to transform raw materials into finished goods. This process is this process is rigorously governed by quality control measures and safety regulations to ensure that the food reaching the consumer is both safe and is of high quality. The continued integration of automation and data science promises to further enhance the efficiency and safety of this vital industry.